Hi, everybody. We're going to do U4, which is find the number of solutions to a system of equations by graphing. So there are three possibilities. You can have the lines that are parallel and they have no solutions. You can have the lines that intersect and they have one solution. And there's another possibility that's odd. There's the possibility that you really don't have a system and they are on top of each other. One way of thinking about it, we say that they're dependent or it's a dependent situation. Anyway, let's do it. I have not previewed it, so I assume that they're going to give us two different forms of graphs maybe. Start out with slope-intercept probably. Yep. So we're going to get a couple of equations in slope-intercept form. It's nice that they color code everything for us. So hopefully all this is clear and you already know how to graph, but I'm just going to do the first one kind of slowly. I'm going to do the magenta or the purple one, x minus 1, and a couple of things that are going on. First of all, there is a number in front of x. It's called a coefficient, and it is 1. And remember that we're looking at y equals mx plus b. Where m is the slope. So the slope is 1 over 1, or negative 1 over negative 1. And b, the b value is negative 1, because you see how it says plus b. Well, that's the same as plus a negative 1. So b is equal to negative 1. The reason we like the b term is because if I put a 0 into this equation, I get negative 1 out. And this is how you interpret a y-intercept. It really should be written as a point. So we write 0, negative 1. And from that point, it's very important. You have to go from a point on the graph, then I can count my slope, which is up 1 over to the right 1. From here, I'm going to go up 1 and over 1. Up 1 and over 1 and up 1 and over 1 and so on. Any one of these points is on this graph of this equation. Now I'm going to graph the green one. And the green one says y equals negative x plus 3. There really is a 1 here in front of the x, even though you don't see it. And the slope is negative 1 over 1. Now, the reason we love 0 is because it's easy to work with, but you could have chosen any number for x. For example, if I chose 2 for x, hopefully everybody can see that if I put a 2 in there and multiply by negative 1 and then add 3, I get 1. 2, 1 is one of my points on that green line, because if I put a 2 in for x, I get a 1 for y. But the thing about 0 is that it's special. We love 0 because when I put x is equal to 0 in this equation, I get 3. There's the number right there. 0, 3 is my y-intercept, and I can then count the slope from there. I go down 1 over 1, and notice that I'm at 1, 2, and then my intersection just happens to be at the 2, 1. That is one of the points that I pointed out there, or kind of so to speak. How many solutions does this system of equations have? It has one solution because they intersect. And that one solution happens to be 2, 1, but there it is. So it has one solution. And I guess that's it. So I think you do have to graph the system. Now this one's kind of interesting. Y equals negative 6 and y equals negative 6. They're kind of giving it away, aren't they? Keep in mind that a lot of people get confused about this one. This is a horizontal line. One way to think of these is that you can say, well, that's the same as 0x minus 6. So my slope is 0 over 1, or just simply 0. Y equals negative 6 looks like this. And I have to graph both of them. So I'm going to graph the green one by putting in y equal to 0, negative 6. 0, negative 6. Notice that y is negative 6. I could also choose 5, negative 6, or 6, negative 6, or any number with negative 6 as the y value. and any point on this line gives me y equals -6. And of course, the blue line is going to be the same. I'm going to go through on the same line, and you can kind of see that they combine the two or put them on top of each other, and they have an infinite number of solutions. And here's what those solutions look like: 0, -6. Now, it isn't any solution because there are lots of points in this graph that you can see all up in here that do not make this true. But any point that includes y equal to -6 is, of course, a solution to both equations. And they are clearly the same equation. So this is infinitely many solutions, and we're ready. I'm going to speed it up a little bit because I'm sure you are getting tired of listening to me. There's the same equation, and they're on top of each other, one way of thinking about it. Hopefully the explanation made sense to you. You do have to graph them both. I'm going to get rid of my writing here, and I'm going to go through 0, -2, and I'm going to have a slope of 1. There's my orange line. Now I'm going to do the blue line. I'm going to go through the same points. I'm going to go through 0, -2. I'm going to have a slope of 1. And there's my two lines that you can sort of see them combining there. And they have infinitely many solutions. But keep in mind, the solutions are only the numbers that are on, or the points that are on these two lines here. Now, there is an infinite number of them, but it isn't all solutions, which is a different situation. Some of you may have thought that this has something to do with this equation. X minus 2 equals x minus 2. Hopefully you remember this kind of equation. It's called an identity, and x can literally be any number. And that is also true for these two. But because y depends on x, there are only a certain number of y values that can be true. And the same thing for the x values. You can choose any x, and then your y's are limited. You can choose any y, but then your x's are limited. But hopefully that I made that clear. And there are infinitely many solutions. Okay, way more explanation than you wanted, but here we go. Same equation again, and I'm not going to go through it again. 2x plus 5. So let's put it in. We go to 0, 5. Hopefully that's clear. And then I count up 2 and over 1, and I'm done. I'm going to go to my orange equation, and I go through 0, 5. And I count up 2 and over 1. And got to hit it again. There we go. And both of my lines are on there. I have infinitely many solutions of the form like these: 0, 5, 1 gives me 7, 2 gives me 9, and so on. -1 gives me 3. And these are all parts of these lines. The other points aren't solutions, so be careful. Infinitely many solutions, same equation. All right, now these are different equations, but they have the same slope. What does that tell you? Think about it. Same slope, different equations. Well, let's take a look and see what they look like. We've got, I'm going to get rid of my dots so that you don't have to look at them. So I'm going to do the purple one first. We're going to go through 0, 2, and we have a slope of -1. Hopefully it's clear. All these points make that purple equation true. Then I'm going to do the green one, and I go through 6, and I have a slope of -1. And all of these points make this equation true. And we say that these two lines are parallel. They never intersect. There are lots of solutions, but none of them are in common. So we say that there are no solutions. This one, I suspect, may have no solutions because we have an equation in standard form and we have an equation in slope-intercept form. Well, when I have an equation in standard form, I love to use the intercepts. 4x minus 3y equals 12. I've taught this before, but I'm going to do it again. I'm going to substitute 0 for x, just like I do when I want the y-intercept in this one. Notice that in the second one, when I put 0 in for x, I got -4. In this one, take a look what happens if I put 0 in for x. When x is 0, what I usually do is I cover this 4x up with my finger. I'm just going to go ahead and make a finger here and cover it up. So there we go. I cover it up, and then I ask myself, -3y equals 12. So I have to solve for y, and that gives me -4, doesn't it? Now I'm gonna erase my finger, take it off. My 4x is hopefully still there. And now I'm going to do the same thing with the y value. Now, I recommend that you be careful and write this point down before you cover it up and before you find your x. There's a reason for it, and it's a weird situation. But here goes the finger. It covers it up. And look what we have. 4x equals 12. So now I divide by 4, and I get my 3. Aren't those beautiful intercepts? Now it's real, people make mistakes on these all the time. Notice that that is a y value. Y value. It is on the y-axis. Is this helping? And it is also called a y-intercept. Y. 0, -4 is my y-intercept. Now look at this one. That is an x value. It is on my x-axis. It is an x-intercept, x. So remember those two. Hopefully it all makes sense to you. I'm going to put my -3y back just so you can see them. Now your other option, which you probably are used to, is you solve this for y. So that is another option, and you can solve this for y. And let's take a look at this. I'm going to go ahead and graph my second equation. Well, actually, you know what? I'm going to graph whichever one they give me first. So I'm going to graph this one using my intercepts. Now, here's my intercepts. 0, -4 for my orange equation. So I'm going to start with that one. I'm going to go through 0, -4. That is a y-intercept. It is very, very easy to make this mistake. Don't do that. That point is -4, 0. This point is 0, -4. And it's really easy to get them confused. That's why I showed you that. 3, 0 is right there, and there's my equation. Now I'm going to graph the blue one. Notice it also goes through 0, -4. If I choose a 0, sorry, I wanted to write. If I choose a 0 right here, hopefully you can see my little pointer there. I don't know if it shows up on the, it's really small. So anyway, if I put a 0 in there, I get y equals -4. So my y-intercept is at 0, -4. Now I can count my slope. It tells me to go up 4, over to the right 3. Go up 1, 2, 3, 4, and to the right 1, 2, 3. And look where I end up. I guarantee that if you solve this orange equation, you're going to get the same as the blue one. This is infinitely many solutions. 2 of them are right here. Those are 2 solutions that make both of them true. So there is an infinite many solutions, and we're done. Okay, I know I went into way too much detail. I'm going to go a little quicker. Same equation, infinitely many solutions. We're at y equals -2, lots of them. Don't forget to graph both of your lines, and infinitely many solutions, and we move on. I'm going to go a little quicker now. Hopefully it's all clear for you. X equals 2. Now this one is not a function. This is the only line that is not a function. X has to be 2. X is always 2 on that line right there. And X is always 2 on this line. Now we can say that there's infinitely many solutions, but they all better look like 2 something, because X is always 2. Not going to go into any more detail on that one. I know you're ready to move on. Okay, so x equals 1 and y equals -3x. I'll bet that you can tell me what the solution is for that system. And this is a system of equations, even though the x equals -1 is not a function. The system tells me that if I put -1 in for x, I get 3 for y. -1, 3 will be my solution, and there will be only one. There can be only one. Okay, so we've got y equals -3x. That's going to go through 0, 0. If I put 0 in for x, I get a 0 for y. I'm going to count my slope. Down 3 over 1 And there it is. Now I want to do the x equals -1. That is a vertical line where x is always -1. And there's my intersection. Like I said, at +1, -3. No, that's not right. What did I do wrong? I graphed x equals +1, didn't I? So let's take those off. Dummy, it's over here. Now we're in the right place. There it is. -1 gives you +3. Oops. Very common error to get your sign wrong on those. Anyway, -1, +3 is my solution. And there is one solution there. God, that would have been embarrassing, especially on the proficient level. All right, we have a pair of equations in what we call standard form. We love these because they allow us to write matrices. Take a look at matrix. The matrix is a system of equations, a big system of equations. For those of you interested in gaming and so on, that's what's happening when you are playing a game in a video game. You're solving big, huge systems of equations, and they're called matrices. And that's how your computer sees it. Your computer sees this thing like this: 1, 2, 1, 1. This is called an augmented matrix, 6, 1. This is my matrix right here, and this is a matrix over here, and this represents that pair of equations. Way more information than you wanted, sorry. We'll do the equation. I'm going to go ahead and, I'm not going to solve for y, although I could. You could solve for y in both cases. Maybe I should do it that way. Let's do it. Let's solve for y. It's not that hard. I'm going to do it quick. Sorry, going off on a tangent. Here we go. So we have x plus 2y equals 6. If I solve this for y, it means I need to get the y alone. You have to subtract x. If you haven't seen Graph Shop, make sure you watch it. It's all about getting that y alone. Divide everything by 2. Remember, we don't want to divide both sides by 2 and get that common denominator and get canceled with the 6. You can't do that. Hopefully you've seen some of my videos before and you know why that's not good. I wanted to divide everything by 2 and I get +3. There's one of my equations. And y equals -1/2 x plus 3. So we're going through 0, 3. Oh, make sure I'm in the right color here. And I am. So this purple one goes through 0, 3 and has a slope of -1/2, down 1/2. Now that's one way to graph that equation. Another way to graph the same equation that I really like is I go ahead and do my intercepts. I put the 0 in for x and I get the 3 for y. I put the 0 in for y and I get the 6 for x. And there's that other point there that you can see. So there's my purple equation. X plus y equals 1. Lots of ways of doing this. I'll bet you most of you can recognize that 0, 1 will be a solution, and that 1, 0 is also a solution. And if you look on here and take a look at all these points, all of them, any of these points on this line, like right here, 3, -2, if I add those together, I get 1. Anyway, thinking about what they really mean, this is one solution, of course. God, I'm going way too slow. I gotta move on. All right, guys. In this one, let's go ahead and graph this guy where you got a 0, -1 and a 2/3 slope. Let's do it. I'm going to graph the blue one. I go through 0, -1 and I have a 2/3. That's up 2 and over 3 and I'm done. For this one, I'm going to go ahead and do my intercepts and I'm just going to write them real quick. 2x minus 3y equals 18. I've got one intercept at 0, 9, 0, -6. Because if I put a 0 in for x, I get a -6 for y. If I put a 0 in for y, I get a 9 for x. So 9, 0 is right there, and 0, -6 is right there. And boy, oh boy, doesn't that look nice? Those look like parallel lines, don't they? That is no solution. You could solve this for y, and you will get a 2/3 slope. 2/3 x minus 6, of course. There's no solution for those guys. All right, I'm going to go faster, I promise. All right, so I'm going to graph the equation, 1/2 x plus 7. Let's graph the purple one first. I'm going to go through 0, 7, and count my slope. That's up 1 and over 2. Done. Now I'm going to do my intercepts. Now I'm going to go really quick. I'm going to let x equal 0, and then I get a 3 for y. 0, 3. I'm going to let my y equal 0, and I get a -6 for x. Now those are parallel, aren't they? That means no solution. Again, you could have solved for y, and you would have found that you had the same slope. What? Did I forget something? What did I do? What did I put one solution? Oh my God. I thought I did it right. Sorry, guys. All right, I'm going to go a little faster. There, now the AI is probably going to keep giving me the same type of equation over and over again because I messed it up. So let's see if I can get this straight. Sorry about that. Oh, man. Cancel. Almost submitted again. All right. If x is 0, y is 2. That's for the blue equation. If y is 0, x is -4. There we go. Now I'm going to graph the orange one, or the red one. I'm going to go through 0, 6, and I have a slope of -1/2, and we have one solution at 4, 4. Sorry about that. Don't know what I was thinking. These have equal slopes, so there's going to be no solution. One of them goes through 0, -3, and has a slope of -3. That's down 3 and over 1. Better make sure I have the right one. And I did. That one goes through, the green one goes through 0, -3, and has a slope of -3. The purple one, or the blue one, goes through -1 and has a slope of -3 over 1. And they are parallel and have no solution. Parallel lines have no solution. I must have saw the N in the 1 or something. I don't know what I was doing. All right. These look sort of similar, but they are different slopes. And a lot of people are going to mess this up. You be careful. They are not going to be parallel. They do not have equal slopes. I go through, I'm going to do the orange one, 0, 1. I have a slope of -1/3. There it is. I'm going to go through 0, 3. I have a slope of -2/3, which is going to go through here. And of course, our solution is at 6, -1, isn't it? And we have one solution. This one, let's graph them. All right, x minus y is -5. Lots of ways to go. I'm going to go ahead and let x equal 0, which gives me 5 for y. Then I'm going to let y equal 0, which gives me -5 for x. There's my green line. There are other ways to go. You could solve this for y, but you're talking about a lot of work on your part. I like using the intercepts. Now for the blue one, I'm going to go through 0, 4. And I have a slope of 1/2. That's up 1 and over 2. And we can see that our solution is -2, 3. And we have one solution. And we're done. In this one, I am going to graph this one first. I'm going to graph the blue one. And if x is 0, y is -1, isn't it? If x is 0, y is -1. If y is 0, x is -1. So there's my blue equation. For my orange equation, I'm going to go through 0, -2, and I have a slope of -1. And those sure look parallel, don't they? That is no solution. Parallel lines have almost hit one solution again. No solution for those. All right, we're getting there. All right, so this one has the same equation, which means an infinite number of solutions. I'm going to use the intercepts. I'm going to do it kind of quick, so hopefully you got it. I'm going to put 0 for x. That gives me y equal to 1. I'm just doing it in my head. It's not that hard. I'm going to let y equal 0 and x is -2. Then I need to do my blue one, which is the same equation. Better get the same line. And there are infinitely many solutions, and we move on. Okay, we've got a weird kind of situation in this one. This very first one isn't in standard form. It's not really in slope-intercept form. I am going to divide all the terms by 4. Rather than thinking of it as dividing both sides by 4, I prefer to divide all the terms by 4. If you were listening before and you didn't quite get what I meant when I said dividing both sides is a bad idea, I'm just going to show you why. Here's what happens to a lot of people. They say, oh, I want to get the y alone, so I'm going to divide by 4. Nothing wrong with that. There's nothing wrong with doing this either. But the problem is that you're going to be very tempted to cancel this 4 with this 4 and this 4 with this 4. And the problem with doing that is that this 4 in the denominator is a common denominator. If I do that and get x plus 8, it will be wrong. So I'm going to show you what to do about this situation. Whenever you divide or multiply in an equation, and this is going to be very useful later in this set, in this section U, later you're going to be doing this over and over again. A good idea, if you multiply or divide on both sides of an equation, think of it as multiplying or dividing into all the terms. I'm going to divide this term by 4. I'm going to divide this term by 4. It will eliminate that weird error, and it will make your life much easier because now I have the right answer, which is y equals x plus 2. Hopefully all that's clear. For this particular one, for the second one, I am just going to add y to both sides, and I end up with negative x plus y equals 2. Now I could add the x to both sides, and I think you're going to see something here. Y equals x plus 2. I just added x. Sorry, 1x if you like. I added x to both sides, and notice that I got the same equation in both cases. So this is an infinite number of solutions, and they go through 0, 2, have a slope of 1. They go through 0, 2, and have a slope of 1. And lots of ways of doing it, but we know that both equations are y equals x plus 2. And there's the equation, and there's the line. There's other ways to do this. Of course, they have an infinitely many solutions. Not all solutions, though. Only the solutions that are on the line. All right. Looking kind of weird here. In that first one, I'm going to change the sign of everything. So in this first equation, which says negative y plus x, oh, what am I doing? Sorry, equals x plus 3. I'm just going to divide everything by negative 1. I can multiply everything by negative 1. The problem is that you have the choice between two things, and sometimes that messes people up. You can also think of it as changing the sign of everything. Y equals negative x minus 3. Same thing anyway. If you divide everything by negative 1, if you multiply everything by negative 1, or you change all the signs, as long as you do everything, to all the terms. Now, in this second equation, I am going to go ahead and add y to both sides. I get y plus x equals negative 3. All I did was add the y to both sides. And then I'm going to go and in this one, I'm going to go ahead and subtract x. So I get y equals negative x minus 3, which looks pretty familiar. Same equation. They're going to be on top of each other. One way to think of it. So I like the y equals negative x minus 3. I'm going to go through 0, negative 3 as a slope of negative 1. Lots of other ways of getting those points. Don't forget to do the orange one. Same 2 points. And they have infinitely many solutions. Okay, we're getting there. All right, this one is another version of standard form. Some books like to get everything equal to 0, and they have a good reason for doing that. The standard form for a quadratic looks sort of like this. So anyway, just wanted to mention that this is sometimes known as a standard form, and then other times this one is standard form. Now this one is going to give you a little bit of trouble because one of my intercepts ends up being a decimal, but it's in the middle, and it may not let me graph it. But let's take a look at that top one. I'm going to go ahead and get it in normal standard form by subtracting 6 from both sides. So I have negative 6x plus 3y equals negative 6. Now this one has some pretty easy intercepts to it. If I put x equal to 0, I get -2 for y. If I let y equal 0, I get 1 for x. So there's my top equation right there. So let's go ahead and take a look at it. I'm going to write my other, I don't have to write it down. It's going to be down here. All right, so let me write my points. There's my points. 0, -2, and 1, 0. These are my intercepts for that, this equation right here. So I go through 0, -2, and 1, 0. There they are. So there's my purple equation. Now I need the green one. Oh boy. The easiest way to do this is, you see how I have a positive y there? I'm going to solve for y. Simple, simple, simple. All I have to do is add 2x to both sides. I'm going to write it, -2x plus y equals -7. And I add 2x to both sides. And look at what we got there. Y equals 2x minus 7. So I'm going to graph it. I'm going to go through 0, -7. Oh, darn it. What was my 0, 1, 0, -2? Oh. Dang, I'm all over the place today. Okay, I have 0, -2 and a 0, 1, 0. Why? I got to get rid of that point. There we go. Now I got it. Sorry, guys. I forgot to push the green button. Now I'm going to go through 0, -7. -7, I said. There. And a slope of 2. The problem is these darn things are getting in the way. Let me get rid of this for now. All right. 0, -7 is my y-intercept, and I have a slope of 2. Oh my goodness. They do not intersect. There's no solution. They have the same slope. And it looks like we might have 1 or 2 more. I'm going to divide everything by 4 in the first equation, and I'm going to write it. And I'm going to write it down below so we can see it better. So in the blue one, I'm going to write y equals x plus 1. All I did is divide everything by 4. So there's my equation for the blue one. I'm going to go through 0, 1, and I have a slope of 1. There, done. Now for the orange one, I'm going to divide everything by -2. See if you can do that in your head. I'm going to get y. I'm dividing by -2. I'm going to get x, and I'm going to get plus 1. Oh, that looks familiar. Same equation, infinitely many solutions on the lines. And I was afraid of that. We get one more left over. Looks like I'm going to divide everything by -6. So let's go down here. Don't let this scare you. Notice how nice it's going to work out. I'm going to divide all the terms by -6. And I'm going to get y equals -2x minus 2. So there's my blue equation. Let's go ahead and put him in there. -2, and I have a slope of -2, down 2 over 1. And I said that. There we go. Not too bad. Now this one is lots of ways to go. I could leave it like it is. It's probably better to add the 12 to both sides. So I'm going to write -12x plus 3y is equal to 12. I just added 12 to both sides. Now I'm going to write my intercepts. I have 0 for x gives me 4 for y, doesn't it? And a 0 for y gives me -1 for x. So -1, 0 is right there. And 0, 4 is up above here, right there. And there's my 2 equations. And they have 1 solution, don't they? Looks like that's my last one. So just before I go, I'm going to go ahead and test it. -1, 0 should be my solution for both equations. If I put in -1, do I get 0? And I do. And if I put in -1 and 0, it is true. 12 minus 12 is 0. So that tends to support that I have the right answer there, if it's true. And 1 solution, and it looks like I'm done. So I hope you guys will go to mastery, and I'll see you back again. Bye.